In this video, I'm going to solve this first order homogeneous differential equation. The equation is dy over dx is equal to y minus 2x e to the power y over x, all of it divided by x. As you probably know, a homogeneous differential equation is a differential equation that could be expressed in this format. The derivative of the dependent variable y is equal to f of y over x. That means you can write the right-hand side of the equation as a function of y over x. An equivalent definition is this, where you have m of xy times dx plus n of xy times dy is equal to 0. This is going to be a homogeneous differential equation if both m and n are homogeneous functions of the same degree. They must have to have the same degree. Now let's go ahead and solve the given differential equation, and it is going to be dy over dx is equal to, I'm gonna break this right hand side into two pieces. It's gonna be y over x minus 2 times e to the power y over x. Now the right hand side is of course is a function of y over x. Okay, f of y over x. Now let's go ahead and make the following assumption. Let's say v is equal to y over x, or y is equal to vx. And if I take the derivative of y with respect to x, I'm going to get dy over dx is equal to, using the product rule, is v times derivative of x with respect to x, which is just 1, plus x times derivative of v with respect to x. Now I will take this value of dy over dx and this value of v and plug it into this equation. And if I did that, I will get on the left hand side dy over dx is equal to v plus x times dv over dx is equal to v, this is v is equal to y over x minus 2 times e to the power v. And this v and v cancel out. That gives me something very simple, which is going to be x dv over dx is equal to negative 2 times e to the power v, or I could write it as dv over e to the power v, which is equal to negative 2 times dx over x. Now I can simplify it slightly more. So I could write this as e to the power negative v dv is equal to negative 2 times dx over x, which I could integrate on both sides, right? With respect to v on the left and with respect to x on the right. So the derivative of this is going to be negative e to the power negative v is equal to negative 2 times ln of absolute value of x plus some arbitrary constant c. Now negative is going to cancel out, right? So I could rewrite it as e to the power negative v is equal to ln of absolute value of x whole square plus some constant c. Now that could further be simplified to 1 over e to the power v is equal to ln of absolute value of x square plus c, that I could rewrite as e to the power v is equal to 1 over ln of absolute value of x whole square plus c. Now v is actually y over x, so I could write this as e to the power y over x is equal to 1 over ln of absolute value of x square plus c. Now I could go ahead and apply ln to both sides again. So I'm gonna go ahead and apply ln just to get rid of the e on the left. So ln of this. So ln and exponential are inverses of each other. So that's gonna give me y over x is equal to, now this, by the way, using the properties of natural log, I could simplify. It's going to be ln1 minus ln of the denominator, which ln1 is of course 0. So there's going to be just negative ln of, let's put it inside the square bracket, ln of absolute value of x whole square, absolute value of x whole square plus some arbitrary constant c, or y of x is equal to then negative x times ln of open square bracket ln absolute value of x square plus c close square bracket, and that should be your final answer. So this should be your solution to this differential equation. I hope that this discussion was helpful. Thank you very much.